Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's video we are going to see the advantages, disadvantages and applications of junction field effect transistor and how it is better as compared to bipolar junction transistor. So let's begin with advantages. The first advantage of JFET is very high input resistance. We know that in case of JFET, the gate source junction is required to be reversed bias and the reverse current is very small. Because of that, the opposition to the flow of current is called as resistance. As the reverse current is very small, therefore the JFET offers very high input resistance. The second advantage, it provides a better thermal stability. The JFET having negative temperature coefficient of resistance. That means as the temperature increases, the current decreases. And because of that, the JFET having better thermal stability as compared to bipolar junction transistor. The next advantage of JFET is that it produces less noise. Whenever the component is used at high frequency, generally it produces more noise. In case of FET, even if it is used at high frequency, it produces less noise as compared to BJT. The next advantage of FET is it produces high gain. As its input resistance is very high, therefore the power gain provided by FET is also very high. Small size and long life, and it is simple to fabricate. The space required for FET is very small as compared to BJT. A very small input current and therefore no loading on the input source. The input current, that means the gate current of FET, is small as compared to base current in BJT, and therefore it has no loading effect on the other device connected to it. These are the some advantages of FET which makes it to use better as compared to BJT. Now let's see some of the features of FET which distinguish it from BJT. The first feature or the very most important feature of FET is that it is a voltage control device. We know that in case of BJT, the base current, that means the input current, controls the output current, output voltage and power, and therefore it is called as current control device. But in case of FET, the gate to source voltage, that means the input voltage, is going to control the output current, that means the drain current. And because of that, the FET is called as voltage control device. The gate source junction is always reversed bias. To operate FET in normal application, like to use FET as an amplifier, we always need to connect gate source junction in the reversed bias. Because for proper operation of FET, the PN junction is required to be reversed bias. If we consider N-channel JFET, then it consists of N-channel semiconducting bar and heavily doped P region, and that forms a PN junction. So we need to make that PN junction reverse bias by applying either by applying a negative VGS or by applying positive drain to source voltage between drain and source terminal. So even if a positive drain to source voltage is applied with gate terminal open, it can cause an effect of reverse biasing of gate to source voltage because of the channel resistance RB. The next feature of JFET is that the gate current is very small. As the input resistance of JFET is very high, therefore the input current, that means the gate current, is very small. The next feature of JFET is high input resistance and capacitance, and it can be used as a switch when it operates in the ohmic region or as an amplifier when it operates in the saturation region. Now we know that in case of ohmic region, the drain current increases linearly with increase in the value of VDS, because in this case the channel simple acts as a resistance and therefore JFET follows Ohm's law. So in this region we can use FET as a switch, whereas in saturation region or in pinch off region the channel is get completely blocked and IDSS value, that means the drain current value, is equals to IDSS, that means when VGS is equals to 0 value. Therefore in that case we can use FET as an amplifier. So these are the few features of FET. Then one of the most important feature of FET as compared to BJT is that it is a unipolar device. That means in case of FET, the current flows either because of the electron or because of the hole, whereas in case of BJT the current flows because of electron as well as hole. In case of FET, the current flow only because of one majority carrier and therefore it is called as unipolar device. Now let's move to the disadvantages of FET. The first disadvantage of FET is that it cannot be used as a current amplifier. As we know, the FET is voltage control device. That means the output current is get controlled by input voltage, that means gate to source voltage, and therefore FET cannot be used as a current amplifier. The second disadvantage of FET is the value of transconductance is very small, as the value of transconductance is nothing but the change in drain current to the change in gate to source voltage. So as drain current changes or drain current increases or decreases, the value of gate to source voltage also increase or decrease. As there is increase in the value of drain current or increase in the value of gate to source voltage, decreases the value of transconductance, and because of that the transconductance of FET is very small. The next disadvantage of FET is the voltage gain of FET is lower than BJT. And the last one, special handling precautions are required to be taken while handling FET, as it is very small in size and compact and light in weight. Therefore we need to take care while fabricating it into the IC or while handling it into the circuit. So these are the some few disadvantages of FET. Now let's see what are the applications where we can use FET. So one of the most important application of FET is that it can be used as an amplifier whenever it is used in the saturation region or whenever it is operate in the pinch off region. The second application of JFET is it is used as a switch. We can use FET as a switch whenever it is operated in the ohmic region, because in the ohmic region the channel semiconducting bar, it simply acts as a resistor and it follows Ohm's law. So as there is increase in the current, there is increase in the voltage. The next application of FET is it can be used as a voltage variable resistor, because we know that whenever we consider channel N channel or P channel JFET, we need to consider the internal channel resistance RA and RB, and the values of that resistance, that means RA and RB, are considered as variable resistor because their values depend upon the magnitude of the voltage applied between drain to source terminal and gate to source terminal. As this voltage it get vary, the value of RA and RB also get vary. The voltage dropped across this resistance causes reverse biasing of gate to source voltage. Therefore, we can use JFET as variable voltage resistor, that means VVR. The next application of JFET is it is used in the integrated circuit. As we know, the FET is smaller in size, light in weight and simple to fabricate as compared to BJT. It is used extensively for the formation of integrated circuit or making of integrated circuit. It can be used in the digital circuit, it can be used in the analog circuit such as A to D converter, D to A converter, amplitude modulation circuit, sample and hold circuit, and many more. So these are the some advantage, disadvantage features and applications of FET. So because of this advantage, disadvantage and applications, the FET is used extensively more as compared to BJT. So I hope you understand this topic. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.